Our next section on graphing quadratics is going to involve completing the square to graph. This is going to be one of those days that those of you who did well with completing the square before are going to find this to be pretty straightforward and simple. Those of you who struggled with that concept are going to have to probably go back and do a little bit of review. But we have basically two forms of our equation we're working with here. We have our vertex form, which is what we started with on the first day, where we looked at an equation like this, and we said, I can take that equation, and my graph is simply moved over 3 up 2. It's a parabola flipped upside down, where we go down 2, down 6. And that we were pretty good with. Now we get to this standard form here. Y equals negative 2x squared plus 12x minus 16. That's the way our equations are going to be presented today. And that's how you're going to come across most quadratics in real-world solving situations. They're going to end up in that form, in that standard form. So just so you're all aware, those two equations are the exact same thing. I've simply multiplied x minus 3 squared, I distributed the negative 2, I combined my like terms. Those two equations are the exact same thing. What we're going to learn to do today is to go from standard form into vertex form, because we found the vertex form graphing to be fairly easy, and we're going to use completing the square to change our standard form into vertex form. Our first example here is going to be an equation like y equals x squared plus 6x plus 7. We're going to go through the process of completing the square in order to get this into our vertex form. So to begin with, when I complete the square, I need to create our blank situation. So I need to subtract 7 from both sides, which gives me x squared plus 6x plus blank. I created that blank situation so I could complete my square. And when I complete the square, we said I always take half the middle term and square it. So I added 9. But if I added 9 to the right side of the problem, I also have to add 9 to the left side of the problem. So on the left side, y minus 7 plus 9 is y plus 2. On the right side, I have x squared plus 6x plus 9, and just like when we did completing the square to solve, I'm going to factor that down to the perfect square we created. Now, in order to get that into vertex form, in order to make that look the way we want, we need y equals. So I'm going to minus 2 from both sides. So my answer here is, I shouldn't say my answer, my equation that I'm going to graph is y equals x plus 3 squared minus 2. So now we've got that nice vertex form that we've learned to graph from to begin with when we did our parent functions, and we can apply our shifts. Plus 3 tells me to go left 3, and negative 2 tells me to go down 2. So there's my vertex. I don't have a number in front, so therefore my growth pattern is up 1 over 1 and up 3 over 1. And my next step would be up 5. That would leave my graph. So I go ahead and sketch in my parabola in vertex form. So this is where the completing the square becomes pretty powerful. In solving, we could always do the quadratic formula if we wanted to. You would never technically have to complete the square. However, when we're graphing, completing the square really is helpful because it changes an equation in that ugly standard form and changes it into vertex form, which we know how to graph from. Our last example we're going to do today is going to be a problem where we have a leading coefficient in our in front of our x squared. And we talked about this when we did our quadratic formula, when we discovered our quadratic formula. In order to begin the problem, I'm going to move the 16 over to the other side. So I get y plus 16 equals negative 3x squared plus 12x. When we discovered our quadratic formula, we said we never complete the square with a number in front of x squared. So I'm going to factor out that negative 3. I divided both terms on that right side by -3. So now I have my completing the square situation. I've created my blank inside my parentheses. So I go ahead and complete the square by taking half of the middle term and squaring it, and I'm going to add 4 on that right side. But because that 4 is inside the parenthesis, it's really 4 times -3. So when I go to add to the other side, I'm going to add -12 to the other side because 4 times -3 is -12. So on the left side, I get y plus 4. On the right side, I'm going to factor my parenthesis just like I always do when I complete the square. X minus 2 squared is the square that I created. And now to get my final form of my answer, I need y equals. So I get rid of plus 4 by minusing 4 over to the other side. So now I'm in my vertex form, -3 times x minus 2 squared minus 4. Now we're able to go ahead and graph that just like we did on our first day of graphing. My vertex is going to be at 2, -4. And as you can see here, I have the issue I'm going off my graph because my multiplier is -3, so I would go down 3 over 1. And my next step would be down 9 over 1 if there was room on my graph. So this is how we graph by completing the square. We're going to create vertex form. The one concept you need to be really careful with, most of you are good at completing the square. You're going to be able to do this example, problems such as this, without too much difficulty. These problems, however, are going to cause us a little bit of trouble because we have to be careful with that -3. We have to remember to factor it out first, and when you complete the square, whatever you put into your blank is going to be multiplied by that -3 or whatever you factored out. All right, good luck, and we'll see you tomorrow.